lots of you have lots of questions about the activities next week. Okay, well, we're in our syllabus, in the schedule, we will have the midterm next week. Let's complete our lectures today, and I will talk more about the midterm. Don't worry too much, I'm very confident. But the thing is to help you read it, okay? The most important is that you have learned something from this course. That is the ultimate goal of this course. So exam is just something for you to realize or to examine yourself if you do learn things or not. And if the learning direction of your idea corresponds consistent with my teaching, that's it. Okay, and yeah. So I'm not particularly interested in having some kind of distribution in the grades. Okay, some of the office people will say, well, we need some kind of distribution. What's the proportion of A plus, proportion of A, proportion of A minus?
No, we don't need that.
When we teach statistics, we have to face the reality, right? So we cannot make the numbers. Right? If the reality is everyone A plus, why not? But the thing is not that I gave you extremely simple questions and everyone get A plus. That doesn't make sense. So we've taught some interesting stuff in statistics, right? So I hope you learn it, and I'll give you some review questions to see if you actually know it, apply it, use it, understand it. Yeah, that's okay. So let me complete our lectures today, and we'll talk about some of the settings for midterm. Okay, so we've got the idea of simple distribution, we are doing estimations, and we have the first example. So let's move forward. So the interpretation of such confidence interval estimator. So some people erroneously interpret the confidence interval estimate in the previous example to mean that there is a 95% probability that the population mean lies between these two values. No, it's not. It's not. This interpretation is wrong because it implies that the population mean is a variable. It's not fixed. Okay? No, it's not. But remember, the fundamental assumption for our statistics, for this course, for classic statistics, is that population parameters are all fixed but unknown. Okay, so such statement is incorrect because it implies that people think population mean is variable. So in fact, the third point, the population mean is a fixed but unknown quantity. So consequently, we cannot interpret the confidence interval estimate of mu as a probability statement about mu. No, it's not probability, it's a proportion. So to translate the confidence interval estimate properly, we must remember that the confidence interval estimate was derived from the sampling distribution of the sample mean. So given a sample, we have sample mean and it's determined. Given this sample mean, we create this confidence interval. So it's either yes or no to capture the unknown population mean. Okay, so it's the proportion. So we use the sampling distribution to make probability statement about X bar. So although the form is changed, the confidence interval estimate is also a probability statement about the sample mean. Okay? So in the example I gave you, the X file I gave you, there is a second sheet, sheet 2. Okay, so move on to sheet 2. You will see we have 20 more samples, each with 25 observations. Right? So in sheet 1, you already got this. And please conduct the same analysis for these 20 extra samples. Okay? And find the values in light blue cells. To determine if the confidence interval obtained from each sample includes the fixed population mean. Okay? In this case, let's assume that the fixed population mean mu to be 350. So this is assumption. So let's assume that the mu is set at 350. Okay, so we have the second sheet number 2. Right, you see we have 20 more samples, each with 25 observations per column. Right, and we gave you the corresponding part with the sheet 1. Okay, so try to find these values in blue cells, the mean for each sample, standard deviation, and n equals 25 for each one, sigma to be 75 for each one, and the alpha confidence interval z are all the same. We set at 0.05. Okay, so what is the LCL and UCL for that particular sample? And given that, what's the width your CI? And if your confidence interval includes the mu, which is 350. Okay, complete this table. Now, yeah, try to play with this, and we will have a, yeah. Okay, so time is yours, and try to complete this table.